the biased current-driven common source stage. Here it is with it is drawn. We have put the current in the FET and we measure the output voltage. Why do we do from current to voltage? Well, if it is driven from another stage, it basically is driven from a current source, GM times V of this the other stage. And if it is loaded, then the V with another stage, then the voltage V is controlling the next current source. So looking at the transimpedance gain of a transistor is not that bad. It's a good perspective if you consider the operation of the transistor. So local feedback in the stage. Let's see how it works. The small signal diagram, oops, there it is again, looks like this. We have local feedback here, and CGS, it doesn't introduce a new pole. It cannot, because there would be a loop of there's a loop of capacitors. So there can only be two poles. But if CGD is not there, we have one pole at the origin and another pole at RLCL. And if we place CGD there, there will be still the pole at the origin, but the gain will be lower. So the loop gain pulse product will be reduced of this pole. And the other pole will shift to a higher frequency. And this is called pole splitting. It occurs if there is a significant voltage gain in the stage and if the feedback capacitance is smaller than the two existing capacitances. And it results in this characteristic, for example. So we don't know what it would be without. I didn't do without CGG. You will find it in a minute. So let's now talk about Cascode states with RC load. So we have then, again, current-driven CS stage, but now cascaded with a common gate. And we know from the common gate, it's a unity gain current amplifier, and there is negative feedback in it. It is parallel at the output, series at the input, a high output impedance, and a low input impedance if the loop gain is high. And the loop gain is high if we drive it from a high output impedance. And this is not so bad in this situation. It can be said that in many applications, practical applications, the loop gain in the CG stage as applied as Cascode is high enough to satisfy the required conditions. So there is a strong reduction of the local capacitive feedback because we are shorting the stage. We are reducing RL. We don't allow voltage gain, basically. If GM of the common gate transistor equals the GM of the common source stage, then we have a voltage gain of unity. And since CGD is always smaller than CGS, we hardly see any effect of it. So there is a strong reduction of local capacitive feedback in the stage by using this Cascode. So the small signal diagram looks like this. Very simple. Basically, you could say CGD now is because of the short in parallel with CGS. That's all. But there's an isolation. And the behavior is like this. The pole splitting is gone. So you see, if this horizontal, if the x-axis in my plot would be a 0 dB line for loop gain, then you can see what happens. If there is pole splitting, now the blue line, the pole occurs when the gain is less than unity. So when the loop gain would be less than unity, which means it cannot contribute to the loop gain pulse product. It's not a dominant pole. But in the green line, if again the x-axis were the 0 dB axis for the loop gain, then the green line, you see the pole occurs when there is loop gain. And it is a dominant pole. So, and you see indeed there where the green line passes the 0 dB line, then in that case is a higher frequency than where the blue line passes. So you see that if we did not use this Cascode, we didn't obtain as much bandwidth as possible from this stage. Bandwidth, I should say, contribution to loop gain pulse product. And we have a few other advantages. So first of all, this stage can be considered as one stage because the second pole, the CG stage, adds a second pole, but it's at FD. It's not dominant. There's also no extra current gain in it because we used a current follower. And a very good advantage is it is a unilateral stage. There's no feedback anymore. There's no influence from output circuitry on input, making it very easy to use cascade connection of those stages because we only have to do with RC networks and isolated poles.